Every single second, somewhere in the world, a condom is being used. Not every minute, not every hour, every second. And behind that quiet, everyday moment is a massive global industry most people never see. Factories working almost non-stop to keep up with one of the most consistent demands on the planet. But here's the question almost nobody asks. Where do all those condoms actually come from? Because the answer is far more complex than you might imagine. Most people think of condoms as a simple product. A thin piece of latex, sealed in a foil wrapper, sitting quietly on a store shelf. But inside one of the world's largest Durex factories, the reality looks very different. Massive production lines stretch across factory floors the size of football fields. Machines move in perfect synchronization, dipping hundreds of glass molds into liquid latex every few seconds. High-speed systems inspect each piece for microscopic defects that the human eye could never detect. And the scale is almost impossible to imagine. Millions of condoms are produced here every single day, because unlike most consumer products, this is something that cannot fail. Every single unit must meet strict safety standards. If even the tiniest flaw is detected, the entire batch can be rejected. So how do these factories manage to produce millions of perfectly tested condoms every day? How do machines ensure that something thinner than a sheet of paper can still be strong enough to do its job? And what does the inside of one of these giant production facilities actually look like? To answer that, we need to go back to the very beginning of the process. Not inside the factory, but in a rubber plantation. The journey of every single condom starts with one simple drop of liquid latex. Once condoms leave the factory floor, their journey is far from over. Because producing
Billions of
is
condoms
only part
distributed
of the story.
worldwide, connecting
The other
continents in a
half is
global
something
health
most
and
people
logistics.
rarely think about. Global distribution. Every year, more than 20 billion condoms are used worldwide. That means factories must supply pharmacies, supermarkets, hospitals, and clinics across more than 150 countries. But transporting a product made from delicate latex requires careful handling. After each condom is sealed in its foil wrapper, they're packed in a protective cartons designed to shield them from heat, pressure, and humidity during transport. From there, a massive logistics network takes over. Some shipments travel by truck to regional warehouses. Others are loaded into cargo containers and shipped across oceans to distribution hubs around the world. Within weeks, products made in a single factory can appear almost anywhere, from pharmacy shelves in Europe to supermarkets in North America or health clinics in developing regions. And when you look at the numbers, the scale becomes incredible. Because even though each condom weighs only a few grams, the total volume shipped every year adds up to thousands of tons moving through the global supply chain. But before any of them reach those shelves, they must pass something even more important. Some of the strictest quality tests in manufacturing. Long before a condom reaches a factory, the process actually begins in a very different place, deep inside tropical rubber plantations. Because the key ingredient in most condoms is natural latex, a milky white liquid that comes from a tree called Hevea brasiliensis, commonly known as the rubber tree. These trees grow mainly in warm, humid regions near the equator, countries like Thailand, Indonesia, and Malaysia, which together produce the majority of the world's natural rubber supply. But latex doesn't come from cutting the tree down. In fact, the tree can keep producing rubber for decades. Instead, trained workers perform a process known as tapping. Using a curved blade, they carefully make a shallow spiral cut in the bark. This cut reaches the latex vessels just beneath the surface, allowing the liquid to slowly drip out. Drop by drop, the latex flows into small collection cups attached to the trunk. Over the course of the morning, a single tree can produce enough latex to be gathered and transported to processing centers. And once collected, that liquid latex will begin its journey towards something most people never connected to: the production lines of a condom factory. Once the liquid latex arrives at the factory, the transformation from raw material to finished condom begins with a process that looks surprisingly simple, but is controlled with incredible precision. Inside the production hall, long automated lines carry hundreds of smooth glass molds shaped like the final product. These molds move slowly along a conveyor system, passing through a series of stations that will eventually turn liquid latex into one of the most widely used protective products in the world. The first step is dipping. Each glass mold is lowered into a tank filled with liquid latex. As the mold is pulled back out, a thin layer of latex sticks to the surface. But here's where things get interesting. The thickness of that layer must be controlled extremely carefully. Too thin, and the condom could break. Too thick, and it loses flexibility and comfort. So the factory controls temperature, viscosity, and dipping time with incredible precision. Even small variations can change the final product. After the first dip, the molds rotate slowly while the latex begins to set. At this stage, a small ring is added at the base, the rolled rim that helps the condom stay in place during use. Then the molds continue down the line into large ovens. Here, the latex is heated in a process called vulcanization. This step strengthens the rubber at a molecular level, transforming it from a sticky liquid into a durable, elastic material. Without vulcanization, latex would remain weak and unstable. And this is where the scale becomes impressive. In large factories, thousands of molds are moving through these production lines at the same time, every minute of the day, which means that every hour, thousands of new condoms are taking shape simultaneously. But making them is only half the challenge. The real challenge is making sure every single one works perfectly, because unlike most products in manufacturing, a condom cannot fail even once. So before a single unit leaves the factory, it must pass through multiple layers of quality control, many of which are surprisingly intense. The first major test happens immediately after the condoms are removed from their molds. At this stage, machines begin performing what's known as the electronic pinhole test. Each condom is placed onto a metal rod and briefly filled with water or electrolyte solution. Then a small electrical current is passed through. If even the tiniest microscopic hole exists, something far too small for the human eye to detect, the current escapes, and the machine instantly rejects that condom. This process happens incredibly fast. Modern testing systems can inspect thousands of condoms every hour, automatically separating any defective units before they move further down the line. But the testing doesn't stop there. In fact, condoms are subjected to some of the most rigorous safety standards in consumer manufacturing. One of the most famous tests is the airburst test. In this test, a condom is mounted on a machine and slowly inflated with air until it bursts. The machine records exactly how much air volume and pressure the condom can withstand before breaking. International safety standards require condoms to survive a specific minimum pressure and expansion level before they're considered safe for sale, and the numbers can be surprising. Many condoms can expand to several times the normal size before finally bursting. This extreme testing ensures that under real-world conditions, the product has a huge margin of safety. But factories don't test just one or two condoms from each batch. They test samples from every production run to ensure consistent quality across millions of units. And sometimes, entire batches are rejected if they fail to meet strict standards. Next comes another important stage, washing. After production and initial testing, condoms are thoroughly washed in large industrial systems designed to remove any remaining residues from the manufacturing process. They pass through multiple rinsing cycles using purified water and gentle detergents. Then they move into drying chambers where controlled heat removes moisture. At this point, the Condoms may also receive a lubricant coating, depending on the product type. This lubricant is carefully measured and applied to ensure consistent coverage. But even now, the process still isn't finished. Before packaging, the condoms go through another round of visual and automated inspection. High-speed cameras scan the surface of each condom, checking for imperfections in shape, thickness, or texture. Advanced optical systems can detect irregularities that would be impossible to notice manually. Only after passing these inspections do the condoms move to the final stage, packaging. Here, each condom is sealed inside an airtight foil wrapper, designed to protect it from oxygen, light, and humidity. 3 factors that can slowly degrade latex over time. These wrappers are printed with expiration dates and batch numbers, so every unit can be traced back to its exact production run. The sealed packages are then grouped into boxes, cartons, and eventually pallets, ready for global
Initiating strength
distribution.
test.
Expansion is
The
stable.
most surprising part of
Approaching
the entire
maximum
process
pressure.
is the rejection rate.
Initiating stretch test.
Even with
Confirmed.
advanced machines
Monitoring.
and
Elasticity
highly
threshold
controlled
reached.
conditions,
No rupture.
a
Excellent.
small percentage of condoms will fail testing and never reach the market. And that's intentional, because in this industry, strict quality control isn't just about maintaining brand reputation. It's about safety. Every test, every inspection, every rejected batch exists for one reason: to ensure that when someone opens a small foil wrapper anywhere in the world, the product inside performs exactly as it should. And when you consider that billions of condoms are produced every year, the level of engineering, testing, and precision behind such a small product becomes truly remarkable. But what might surprise you most is that even after all these automated systems, machines, and inspections, human experts are still involved in monitoring the process. Because in a factory producing millions of
Pressure
units
tests
per
are
day,
solid, well above the
the
threshold.
smallest detail can make the
Elasticity is
biggest
consistent,
difference.
99.9
Once
probability.
condoms pass every quality test, they finally move to the last stage of the process: packaging. At this point, the products that remain on the production line have already survived some of the strictest safety checks in manufacturing. Electronic inspections, pressure tests, visual scans, and laboratory sampling have all confirmed that they meet international safety standards. Now the focus shifts from testing to protection. Each condom moves into a high-speed packaging system where it is carefully folded and placed between 2 thin layers of aluminum foil. The wrapper is then sealed using heat and pressure, creating an airtight package designed to protect the latex from oxygen, humidity, and light. These factors might seem harmless, but over time, they can slowly weaken latex. The foil wrapper acts as a protective barrier that keeps the condom stable and safe to use for years. Before the package leaves the machine, several important details are printed onto the wrapper: the production batch number, manufacturing date, and expiration date. This information allows manufacturers to trace every single unit back to its exact production line if necessary. From there, the sealed wrappers continue along automated conveyors where they're counted, sorted, and grouped into retail boxes. Some packaging machines operate at incredible speeds, organizing hundreds of condoms every minute and stacking them into familiar boxes seen in pharmacies and supermarkets around the world. Those boxes are then packed into larger cartons and stacked onto pallets, ready for shipment. Within hours, pallets filled with products that started as liquid latex just days earlier are loaded onto trucks and transported to distribution centers. From there, the journey continues across a global network of warehouses, shipping routes, and logistics hubs, eventually reaching pharmacies, supermarkets, convenience stores, hospitals, and clinics in more than 150 countries worldwide. And sooner or later, those small foil packets end up somewhere very ordinary, on a store shelf, inside a drawer, or in someone's pocket. Which is what makes this entire process so fascinating. Because something that appears incredibly simple, a thin piece of latex sealed in a small foil wrapper is actually the result of an enormous global system working quietly behind the scenes. From rubber trees growing in tropical plantations, to automated production lines running day and night, to strict quality testing designed to detect even microscopic defects, every single condom represents a carefully engineered product designed to protect millions of people every day. And the next time you see one sitting quietly on a store shelf, remember, behind that tiny package is an entire industry of engineers, scientists, machines, and workers making sure something so small performs exactly as it should